So since we had a break, I'm going to start with just some straightforward, pretty much straightforward derivatives, and then also find out where the derivative equals 0. And for the first one, it's going to be the product rule. So the derivative of x is 1, and then leave the e function alone, plus leave x alone, and take the derivative of the e function, which is the e function. And then it's time for the chain rule. So take the derivative of negative x squared, that's negative 2x. And then set it equal to 0. So each of them has the e function, so I could factor that out. And then what it would leave behind would be the 1 and then minus 2x squared. So the e function never equals 0, so I don't need to set that one equal to 0, but for this polynomial, 1 minus 2x squared, that could equal 0. So I could add the 2x squared to both sides. And then I'll need to finish it over here. So you could divide both sides by 2. And then take the square root. So the square root of 1 will just be 1. And on the bottom, the square root of 2 is the square root of 2. And then when you take the square root of both sides, put plus and minus. And then I think I want to check that one real quick. So graph the function x times e to the negative x squared. X times e to the negative x squared. And it looks like there's two places where the derivative equals 0. One would be right there where it says the maximum. So that's 0.707. And then calculate and type in 1 divided by the square root of 2. And that is the 0.707. And then the other one would be the negative value, negative 0.707. So there's a minimum and then a maximum. So any questions on that one? No, it's okay. And then for part B, again, use the product rule. So the derivative of the e function will be the e function itself. And then do the chain rule. So the derivative of negative 2x will be negative 2. And then leave sign alone. And it looks like I'm going to need some more space. Let me just move it over there. Okay. So in the middle of the product rule, then it goes plus, leave the e function alone. And then take the derivative of sine, which is cosine. And set it equal to 0. And like with the last one, they each have the e function, so you could factor that out. And then what's left is negative 2 sine of x plus cosine of x. And then set each factor equal to 0, although the e function will never equal 0, so that's not going to give us any solutions, but negative 2 sine x plus cosine x, that could equal 0. So I could add the 2 sine x to both sides, and then I would say cosine of x equals a positive 2 sine of x. And then in order to get this to become one trig function, I'm going to divide both sides by cosine. Because then on the right side, there's sine divided by cosine, so that's tangent. And next, divide both sides by 2. So it says, when does tangent equal a half? So for that, use tangent inverse. Let me make sure this is in radians. Yep, it is in radians. And then tangent inverse of a half, 0.646. I wonder if that's pi divided by something. I'm going to try. If you divide it by pi, and then you convert that to a fraction, is it a fraction? Nope, it's not. So I just have to use the 0.646. Six, 4, 6. And then because tangent equals 1/2 over and over again, you could just add a multiple of its period, which is pi. So just n times pi, or some places put k times pi. And then that would be all of the places where tangent equals a half. And then on to number 2. So find the derivative, but notice it's with respect to t, as in time. So when you take the derivative of e to the y, that would be e to the y. But then you need to take the derivative of y with respect to t, plus, then take the derivative of e to the x. So that's going to be e to the x. But then you also need to take the derivative of x with respect to t. And then on the right side, the derivative of 4 is 0. So in the directions, I said to find the derivative dy dt. So we need to solve for that green blob right there. So we could leave that on the left side for now. E to the y times dy dt equals negative e to the x times dx dt. And then the last step, to solve for dy dt, just divide both sides by e to the y. And then the numerator stays the same. So any questions so far? No? Okay, then for part B. So for part B, I think I'm going to do pre-calculus before I take the derivatives. On the left side, I'm going to use the rule for logarithms that said you could break this into two logarithms. It would be the natural log of x plus the natural log of y. Because that way I don't have to use the product rule. So basically just taking one more complicated function and dividing it into two easier ones. And now take the derivative of the natural log of x. So that would be 1 over x. And then once again, the chain rules. So take the derivative of x, that'll be dx dt, and multiply those two. For the natural log of y, it's almost exactly the same. It's 1 over y, and then dy dt. And on the right side, it would be derivative of t with respect to t, but dt divided by tt equals a 1. So I'll replace that with just a 1. And then the last two steps are going to be similar to the last two steps of the other one. To solve for the dy dt, I'll first move this 1 over x term to the right side, so subtract. So it'll be 1 minus 1 over x dx dt. And then the last thing is to solve for dy dt, just multiply both sides by y. And then you could either leave it like that or you could distribute. I haven't used the distributive property for a little while, so I'm just going to practice that. So multiply by y. And then this one will be y over x times dx dt. And then just wrap it up in a nice little oval shape. So I think I'm going to graph this one first. Find the equation of the tangent line and then the graph. So this one, it's not solved for y. So that means that my TI-84 is not going to graph it. So I'm going to use Desmos. There we go. So x, hey, where's my x? X squared plus sine of y, and then it equals a 2. Whoa, I did not expect that. Sort of an hourglass shape that's repeated over and over. Okay, then when, I think I said x equals 1. I guess that's that point right there. And then looking at that, if you make it the tangent line, that's actually going to be vertical. So actually, I guess I should have graphed this problem first before doing it, because we're going to get no solution. Well, let's see if that happens. So for one thing, it said where x equals 1. So I do need to know the y value. And Desmos told me it's pi over 2, but I want to see why that is. So if you plug in x equals 1, this would be 1 squared plus sine of y equals 2. And then you could subtract 1 from both sides. So that's sine of y equals 1. And then sine goes like this. It's equal to 1 right here. Right there, that would be pi. So right there, that's pi over 2. So that means the y value is pi over 2. So Desmos actually had it right. Okay, now for the calculus part, take the derivative. So the derivative of x squared is 2x. The derivative of sine is going to be cosine of y. Then we need to take the derivative of y, so that's dy dx, or y prime for short. And then the derivative of 2 equals 0. Now to solve for y prime, I could either do the algebra to solve for y prime first, and then plug in the 1 for x and the pi over 2 for y, or I could switch the order and plug in the numbers right now. I think I'm going to do that. So 2x would become 2 times 1 plus cosine of, then y is pi over 2. So this would be 2 plus, and cosine of pi over 2. Well, there's cosine up to 2 pi. So in the middle is pi. So it's actually right here that's pi over 2. So cosine of pi over 2 is equal to 0. So this is going to be 0 times y prime. And then, of course, 0 times y prime is just 0. So that means that the equation says that 2 is equal to 0. And there are very few times in life when 2 is equal to 0. So that's why there's no solution, because it's a vertical tangent line. But you know what? There's no solution for y prime, but if I'm able to say the words, there's a vertical tangent line, then I should be able to find the equation of that line. So the point was right here. Why is my pen not working? The point is right here. And then I need the equation for this vertical tangent line. And I can't do it by using the derivative, but I could do it by using that the point is 1 comma pi over 2. So Daisy, you know what the equation of that line is going to be? Jose, do you know what it's going to be?
X equals 1.
So the equation of this line is x equals 1. Because no matter where you go along the line, it has to be lined up where x is equal to 1. So the whole time x is equal to 1. And then it doesn't say what y is in my equation. That's because the y could be anything. It can just keep going and be any number, but x always has to equal 1. And if it was, for some reason, if it was a horizontal line like this line right here, then that would be y equals -2. That's not a tangent line, but for a vertical line, it's always going to be just x equals a number. And for a horizontal line, it's always going to be just y equals a number. Okay, now I need to move that so I can see the next part. Let me see, the cube root of 8 is 2. plus another cube root of 8, 2 plus 2 equals 4. Okay, so this one is set up fine. Then find the second derivative with respect to x. So do the power rule. It would be 1/3 x, and then subtract 1. So 1/3 minus 1 is going to be negative 2/3. And then for this one, we're taking the derivative with respect to x. So then it would be the derivative of x with respect to x is a 1. So you could put times 1. But since that's not going to change the problem, you don't have to put it. And then for y, it's going to look very similar, plus 1/3 y to the negative 2/3. And then take the derivative of y, which is either dy dx or it's y prime. And on the right, it equals 0. So we could go ahead and start taking the second derivative, but I think it would be better to simplify and solve for y prime. So one thing I'm going to do is I'm going to multiply both sides by 3, because that's going to get rid of those little fractions, the 1/3. And I'm also going to get rid of the negative exponents. So this is going to be 1 over x to the 2/3. This one is going to be 1 over y to the 2/3 times y prime. And then it still equals 0. And then the next thing to do is subtract the 1 over x to the 2/3 from both sides. And then to solve for y prime, multiply both sides by y to the 2/3. So on the left, the only thing that remains is y prime. And on the right, there's negative x to the 2/3 over y to the 2/3. So now we're done with the first derivative. Now time for the second derivative.
Isn't the y supposed to be on top?
Oh yeah, I switched them. Huh, thanks. The y's on top. The x is on bottom. That's a sloppy x. Okay, now we're ready for the second derivative. So the negative could stay there, and then we'll need to do the quotient rule. And I don't think I'm gonna have enough room. Need some more space. Okay, so starting on the top, the derivative would be 2/3. Bring that in front of the y and multiply, and then subtract 1. And 2/3 minus 1 will be negative 1/3. And then just leave the x alone. And then the quotient rule has minus. Now leave the y term alone and take the derivative of the x to the 2/3. So that will be 2/3 x, and then subtract 1, so that'll be negative 1/3 exponent. And then the last part of the quotient rule says the bottom needs to be squared. And then when you raise a power to another power, you multiply them. So that's going to be x to the 4/3. x to the 4/3. All right. Now I need to clean this up. Or I could just plug in the numbers. So again, it's one of those, you could do the algebra and simplifying first and then plug in the numbers, or you could plug in the numbers first. I think I'll plug in the numbers. So the negatives in front, and then it's 2/3, and then an 8 is raised to the negative 1/3, and an 8 is raised to a 2/3, minus, and then the other one is going to have the 2/3, and then the y is an 8 raised to a 2/3, and then the x is an 8 raised to a negative 1/3. And on the bottom, 8 is raised to the 4/3. And I'm pretty sure that the answer is 0, because this one has an 8 raised to a negative 1/3, and this one also. This one has an 8 to a 2/3, and then so does this one. And this one has the 2/3, and this one has the 2/3. So that means that they're the same. And then finally, this part is saying subtract them. So it's equal to 0. I thought that one was going to take longer, but nice, it equals 0. And then for extra fun, I'm going to graph the original and see if I could understand why the second derivative would equal 0. So usually that happens when you've got, like, it's going from concave down to concave up. Then right there, that's where the second derivative would equal 0. So that would be an inflection point. So I'm going to graph it and see, does it seem like it's an inflection point? So x to the 1/3, y to the 1/3 equals 4. And again, it's not solved for y, so I'll need to use Desmos. So x is raised to the 1/3, and plus y is raised to the 1/3, and then it equals a 4. It's not letting me put a point on there. And that does not look like it's changing from concave up to concave down. That looks like it's concave up the whole time. Did I miss something? I don't see what I'm missing. I believe it's 0. Oh, well. Did I type it in Desmos correctly? Whoops, that's not it. That's Desmos. X to the 1/3 plus y to the 1/3 equals 4.
You're
And it's,
supposed to get the derivative though. That's how
what's that?
that's you got 0 by the second derivative, right?
Yeah,
So what would you think the first one was supposed to look like?
I was thinking that the graph is going to look more like this,
Uh,
but it's looking like this, which is concave up all the time. Now, the thing is, when the derivatives equal 0, it's only possible that there's an inflection point when the second derivative equals 0. Just like with the first derivative, if you have a function like x cubed that looks like this, so right there, the derivative equals 0, but it's neither a minimum or a maximum point. It's only possible that it's a minimum or maximum. And with the second derivative, when a second derivative equals 0, it's possible that it's an inflection point, but no guarantee. Well, we've still got quite a few other problems to work on, so I'm just going to stick with that and go on to the next one. So this one is a related rates problem because it's giving us one rate and then asking for another rate. And we can't plug in the numbers until after we take the derivative. So starting with the w squared, so that would be 2w, and then the derivative of w with respect to t. Then move on to this term. So for this one, we need to use the product rule, and I'm going to put the 2, the pi, and the r together, because 2 pi is just a constant, and then the w as the other term. So take the derivative of this blue part right here, and that'll be 2 pi, and then take the derivative of r with respect to t. And then the w, for now, you just leave it alone. Plus, now leave the 2 pi r alone, and now take the derivative of w. So derivative of w with respect to t. And on the right side, the derivative of 9 is 0. So then it's time to plug in the numbers. So I've got that r equals 1, so that's going to go right here. I've got dw dt equals a 7, so that's going to go right here. But then this one and this one also both say you need to know what w equals. So that means we need to go back to the original function and plug in the r equals 1 and then solve for w. So this calculus part is going to have to take a break while we go over here and do intermediate algebra. So w squared plus 2 pi, and then replace the r with the 1 times w equals 9. Then it's got a w squared and also a w and also a constant. So that means we're going to need to use the quadratic formula. So first, subtract 9 from both sides and set it equal to 0. And then do the quadratic formula. So that's going to be, the b term is the 2 pi, so negative 2 pi plus or minus the square root, and then 2 pi gets squared minus 4 times the a, which is 1, and the c, which is negative 9. And then all divided by 2. So then I could simplify what's inside the radical a little bit, because 2 pi being squared is going to be 4 pi squared, and then plus a 36. And then what are the decimal answers for that? So there was a negative 2 pi, and then plus the square root of 4 pi squared plus 36. Then put all that in parentheses and divide by 2. So 1.202. And then do the same thing with this being the minus the square root. Negative 7.486. So W equals either a 1.202 or W equals a negative 7.486. Well, since I'm going to have to do this twice in the equation that we got from the derivative, should I plug it in and do the algebra? Yeah, I guess I'll just plug in the numbers. So I'll just pick the first one. Oops, I had the eraser instead of the pen. 1.202. So I'll do that one first. So 2 times 1.202, and then dw dt, that was given to be 7. And then 2 pi times dr dt, and then times w, so 1.202 plus 2 pi, and then replace r with the 1, and then times dw dt, so that's a 7, equals 0. So then I'm going to combine these two green blobs, because they don't have any variables, those are just numbers. So I need to know 2 times 1.202 times 7 plus 2 pi times 7. So 2 times 1.202 times 7 plus 2 pi times 7 times 7, a 60.81. So since that equals 60.81, I could then subtract 60.81 from both sides. So it's going to equal negative 60.81. And then finally, to solve for dr dt, divide both sides by both a 2 pi and a 1.202. So the calculator already has the 60.81, but it actually has to be negative. So negative 60.81, whoops, 81 gets divided by, and then put it in parentheses, 2 pi times a 1.202. So a negative 8.052. And then I don't have enough space or enough time to do the other W. So we'll just pretend in the directions I said for W positive. There you go. So use the derivative to find out where the function is increasing. So in other words, increasing means that the first derivative is positive. So for number 6, find the derivative and find out where it's positive. So this one is going to be the quotient rule. The derivative on top, the derivative of x plus 1 is just a 1. And then times the bottom one, x squared plus 1, minus, just copy down the x plus 1, and then take the derivative of x squared plus 1 is 2x. And the last part of the quotient rule, the bottom gets squared. Now this little part right here is going to save us some work, because on the bottom, when you square something, it's going to be positive. So if our answer is supposed to be positive, that means we need to know when is the top positive, because the bottom's already positive. So all I really need to do is just take the top part and find out where that's positive. So let's see, the top part has an x squared plus 1 times 1, and then distribute. So this is going to be 2x squared, but with a minus sign, so minus 2x squared. And then this part would be 2x, but also with a minus sign, so minus 2x. So when is that positive? Well, I could combine the like terms, negative x squared, and then minus 2x, and plus 1, and where is that positive? Well, in order to find out where it's positive, what I'll do is I'll set it equal to 0, because 0 is the dividing number between the positives and the negatives. So once again, the quadratic formula, x equals negative b, so negative of negative 2, plus or minus the square root, the b gets squared, minus 4 times the a, which is negative 1, and the c, which is 1, all divided by 2 times the a. So this is going to be a positive 2 plus or minus. And then inside the radical, I believe that's an 8. Because negative 2 squared, that's going to be 4. And then this is a negative times negative, so that means another 4. And a 4 plus a 4, that's an 8. So 2 plus or minus the square root of 8 over negative 2. So 2 plus the square root of 8 divided by negative 2. Negative 2.414 is one answer. And then do the same thing, but change it to minus the square root. And then that's a 0.414. So if you go back to this line, we're trying to find out when this thing is positive. Well, because it has negative x squared, that means it's an upside down parabola. And when it equals 0, we got over here on the negative side, negative 2.414. And over on the positive side, a 0.414. And for the parabola to be positive, that would be all of this part. So that means between the two numbers, so between negative 2.414 and positive 414, that is where it's positive. Any questions on that one? Okay, so I'm going to graph it and see if it looks right. So the original function had x plus 1 over x squared plus 1. I could do that one on this calculator. On the top, it's x plus 1. On the bottom, it's x squared plus 1. So when it gets to the top right there, that's the positive 0.414. So that looks right. And then over here somewhere, right there, that's where it's at the minimum. And that's the negative 2.414 that we got. And as you go from there to here, the function is going up, which means the derivative is positive. So it's increasing between those two. Awesome. And then onto this little word problem. So there's a box that has a square base and an open top. Let's see if I remember how to draw these. So it has to have a square base. And then I draw another one over here. Well, that's okay. I wanted my box to look like it was standing up tall, but this one, it fell over. It's laying on its side. So I'm really calling this blue side right here the base of it, but somebody pushed the box over. So if it's a square, it's got to be x by x. And then this length right here, I don't know what that is, so I need a whole new variable. I'll call it y. So this side is y. And then this is about the volume. So volume, for a rectangular prism, you just multiply the three sides. So it's going to be x times x, or x squared, times y. And when doing problems like this, there's basically going to be one area where we do algebra, and then one area where we do calculus. And right now I'm doing the algebra part. So the volume is 32,000. So I could plug that in for the volume. 32,000 equals x squared times y. And then I could use that to either solve for x or y. I'm not sure which one I should solve for, so I'm just going to wait, and I'm going to go work on the calculus part, and then I'll come back to the algebra part. So the question is about minimize. So we'll need to take the derivative and set it equal to 0 to find the minimum. And then the question is about the material required to construct the box. Well, that means that we need to find out how much area this is. And that would be x times x. So the amount of material, I'll just call it m for material. So this front side would be x times x, or x squared. And the back of the box is going to be the same, so another x squared. So there's two of them that have x squared. And then this right side of the box right here, its area would be x times y. And this left side of the box would be the same, so that would be another x times y. And the bottom of the box is also going to be an x times y. And it says that it has an open top, so we don't need that. But from those three other sides, we have three of them that are x times y. Okay, so now we need to use this algebra and either solve for x or solve for y. Well, if I go to solve for x, I'm going to have to take the square root, and then we'll have to do the derivative with the square root. I think instead what I'll do is I'll just divide both sides by the x squared. And just solve for the y. So now going back to the calculus part, I'm going to take that and plug it in for this y right here. So 2x squared plus 3x times, and replace the y with 32,000 over x squared. You know, each time I make up these, I space them out more and more and more. And then I look at it and I'm like, I'm going to have plenty of space. I don't need to space it out anymore. Maybe I should just put one question per page. Okay, so right here, there's going to be a 3 times 32,000. So 3 times 3 would be 9. 3 times 2 would be 6. And then it would have 3 zeros after that. And then 1x will cancel 1x, so it's still divided by an x. And then take the derivative. So the first one, the derivative is just going to be 4x. And the next one, I basically just look at it as if it was 1 over x. And the derivative of 1 over x is negative 1 over x squared. And the 96,000 could just stay there. So it's going to be minus 96,000 over x squared. And then where does the derivative equal 0? So I could take the term with the 96,000 and then add it to both sides. So it becomes a positive 96,000 over x squared. And then equals 4x. And then multiply both sides by x squared. So the left side will just have 96,000. The right side will have 4x cubed. And then divide both sides by 4. And then the last thing is take the cube root of both sides. So 96,000 divided by 4. And also take the cube root of that. 96,000 divided by 4 and take the cube root. So a 28.845. 28.845. And then in the directions, I said find the dimensions. So we need to find both x and y. So I could use this equation right here. To find out what y equals. So then y equals 32,000 divided by x, so that's 28.845 gets squared. So 32,000 divided by the 28.845 gets squared. It's a 38.46. So finally, the box is 28.845 inches by 28.845 inches by 38.460 inches. And there's the dimensions of the box. And then I did throw in this last problem, although I didn't think we'd have time for it. Do you guys want to do it or just call it a day?
I might have time.
You have time? All right. We have time, but now I just need space. Oh yeah, that's a image. Okay, so for this last one, a water trough has ends that are equilateral triangles. So let me try to draw a nice, neat equilateral triangle. And the side length are 2 feet. So equilateral means they're all the same. And then back over here, farther away, would be another equilateral triangle. And then the trough, whoops, I should have made the triangle bigger. Anyway, the trough goes like that. And then you could fill it up with water and horses could drink out of it, or cows or goats or something like that. And of course, it would have to have some type of stand so that it doesn't flop over. So as the water level is rising, at some point, the water is going to be up to like right here. And I don't know what the height that is because it's actually changing. So then I'll have to measure from the bottom up to there. And then that's going to be the height h. And then another thing that I don't know that's a variable is if you go from there straight across to the side, how long is that? And since I don't know what that is, it's going to be x. Well, this part right here that says cubic feet, that's volume. So we need to find out what's the volume of water. Well, this is a triangular prism. So basically you just find the area of this triangle right here. And then because it's 5 feet long, you just multiply that by 5. Well, area is 1/2 times the base times the height, and then multiply that by 5. And the base of that triangle is actually 2 x's, because I counted x as the left side, which means by symmetry, there'd be another x on the right side. So the base of that triangle is going to be 2x, and the height is h. And then actually the 1/2 and the 2 are going to cancel each other out. So there's really just 5 times x times h. And then this part is saying derivative. And then this part is talking about the height. So in other words, find dh dt. Since we're supposed to find dh dt, it's good that this has an h, but I don't want the x. So I'm going to have to do some other algebra, in this case, geometry, to find out what x equals. And here's the main reason that I picked this one. So when you look at the face of the water trough, when I first started, It's a triangle that's 2 feet by 2 feet by 2 feet. And if you split that down the middle, that means the 2 feet is going to be 1 foot on this side and 1 foot on this side. So that's basically splitting it right here, right there. And then if you look at where the red X is, well, that's a triangle that goes like this. So it's basically just a smaller version of the 2 by 2 by 2. But this one has X and X on the top. And it has H for its height. Now, the next thing I want to do is just look at this triangle that's on the left and compare it with this triangle that's on the left. So those are similar triangles. They have the same angle at the bottom and they have the 90 degrees. And so those are similar triangles. So for this one that's on the left, this is a 1, this is a 2. And if you do the Pythagorean theorem, this is going to be the square root of 3. Because that way 1 squared plus square root of 3 squared, that equals 1 plus 3, that equals 2 squared. And for this little one, this side is X and this side is H. And that's all I need off of that one. And then I could do proportions. So X compares to 1, just as H compares to the square root of 3. So X compared to 1 equals H compared to the square root of 3. And then if I multiply both sides of by the square root of 3, it's going to say H equals the square root of 3 times X. And that is what I needed from all of that geometry right there. H can be replaced with the square root of 3 times X. So now back to our equation over here. So 5 times, and then, oh, actually I wanted to replace X, not H. So actually X divided by 1, that's already X. So X could be replaced with H divided by square root of 3. Yeah, that's the one we need. So H divided by square root of 3 replaces the X, and then there's that extra H right there. Or in other words, after all of that work, 5 divided by square root of 3 times H squared. And now we're finally done with all of the preliminary geometry and algebra, and now we're ready to do the calculus. So now take the derivative. So the derivative of volume with respect to time equals, and then take the derivative of H squared, which is going to be 2H. And then by the chain rule, stop doing that. And then by the chain rule, you could take the derivative of H with respect to T. And now we're almost done. So this part right here, that's the change of the volume over the change of time. So that means that goes right here for the dv dt. And then the thing is, we also need a number for this h right here. And that's where the 13 minutes comes in. So in 13 minutes, if it's going at 0.5 cubic feet per minute, and then you let that go for 13 minutes, well, then the minutes are going to cancel out, and it's a half of 13, so that's 6.5 cubic feet. So that's equal to the volume. So now I could use this one before I took the derivative, and then I could plug in the 6.5 for the volume. And then I could find out what h equals. So it's going to be 6.5 times the square root of 3, and then divide both sides by 5. And then that's what h squared would equal. And then to solve for h, take the square root of all that. 6.5, the square root of 3 divided by 5, and the whole thing is still square root. So the square root of a 6.5 and then a square root of 3. And still inside the square root, put divided by 5. So it's about 1.5 feet, 1.501. So the height equals 1.501. So the dv dt, that is a 0.5. So on this side, it's a 0.5. And then there's 5 over radical 3 times 2h. So that's 2 times 1.501. And then dh dt. So to solve for dh dt, you could multiply both sides by square root of 3. And then divide both sides by this number, which is going to be 10 times 1.501. So if it's a 10 times it, it just moves the decimal by 1. So that means it's a 15.01. And then just put that in a calculator and we're done. So 0.5. Oops, I forgot to write it down. I need a 0.5, a square root of 3 divided by 15.01. 0.5 times the square root of 3 and then divided by 15.01. And it's a very small number, 0.058. And the units would be, this is in feet and minutes, so feet per minute.